So, your organization is deploying AI. Well, there's a critical and honestly an often overlooked risk you have to understand. It's called training data leakage. This is what happens when your AI model stops just learning from your data and starts, well, memorizing it. And the things it might memorize, we're talking about your company's most sensitive information, from customer PII to confidential strategy documents.
So let's start with the big question that every CISO, every compliance officer, really everyone should be asking. What are the actual real-world consequences when your AI, the very tool you've built to be a helpful assistant, suddenly develops a photographic memory for things it was never, ever supposed to repeat?
And look, this isn't some theoretical what-if scenario. These are real incidents, and they have massive consequences. We've all seen the headlines about GitHub's Copilot reproducing copyrighted code verbatim, which sparked huge lawsuits. We've seen researchers cleverly prompt ChatGPT to spit out personal user data it had memorized from its training set. And just this year, a healthcare chatbot leaked sensitive patient info, triggering major HIPAA violations. Another company's internal LLM shared confidential strategy docs with the wrong employees. This is happening right now. Okay, so we've seen the damage this can cause, but why does this happen? This isn't just a simple bug you can patch. It's actually a fundamental characteristic of how these models are built. Let's call it the photographic memory problem. Let's get a really clear, manager-focused definition on the table. Training data leakage happens when your model, completely unintentionally, memorizes and then reproduces sensitive info from the data it was trained on. We're talking personal information, trade secrets, copyrighted content, you name it. It's a recipe for a privacy and compliance nightmare. This analogy just perfectly nails the problem. Imagine you hire an employee with a perfect memory. You want them to learn all your company's processes, right? Well, they'll learn them perfectly, but they'll also perfectly remember every single customer name, every account number, every private detail they see along the way. You can't just go up to them and say, hey, could you just forget that customer's data? It doesn't work that way. An AI model's memory is exactly the same. It's all one big, unified system. You know, it's absolutely crucial to get the difference between good learning and dangerous memorization. What we want is for our models to generalize patterns, to learn the concept of a helpful email, for instance. What we absolutely don't want is for it to reproduce word for word a specific customer's private email. And that dangerous kind of memorization, it often happens when data is unique or gets repeated over and over again in the training set. So, what is it about today's AI models that makes them so prone to this? Well, it boils down to something called overparameterization. That sounds technical, but think of it like this. Modern LLMs are built like these enormous, cavernous warehouses with way more space than they actually need. And to fill up all that extra room, they don't just store the general patterns, the blueprints. They start storing the actual items themselves, the specific verbatim examples from your data. And this brings us to probably the most critical, non-negotiable fact you need to understand about this whole topic: the permanence problem. Your training data doesn't just teach the model, it becomes a permanent, baked-in part of its structure. Once that sensitive customer record is learned, it's in there for good. There is no undo button. There's no way to just surgically remove it later. This is exactly why prevention is the only real strategy you have. Okay, so if we can't fix a leak after it's happened, how on earth do we prevent it in the first place? The answer is what we call a defense-in-depth strategy. You can't just rely on one single fix. You need a structured, four-stage plan that puts up shields across the entire AI lifecycle. Stage 1 is data curation. And let me be clear, this is your most powerful line of defense. This all happens before you even start training the model. You filter out PII and secrets, you apply data minimization principles, which, by the way, is a requirement under GDPR, and you check the licenses for your data sources. In short, if you don't want the model to learn it, don't let it see it in the first place. Now, here's a very common and very dangerous mistake people make. They think, oh, we just anonymize the data, so we're good to go. The reality is that simple redaction or anonymization just doesn't cut it. These models are so good at pattern recognition, they can often piece together someone's identity from context clues. It's called a re-identification attack. True safety requires much more sophisticated techniques. All right, stage 2. This is what we do during the training process itself. We can apply some really smart technical controls here. For example, using differential privacy adds a bit of mathematical noise to the data. It basically makes it harder for the model to zero in on and memorize the details of any single person. Another huge step is deduplicating your data. Remember,
Repetition is what drives memorization. So the fewer times a model sees a unique piece of info, the less likely it is to spit it back out. And here is a massive warning, especially for any teams working on custom AI models. It feels counterintuitive, but fine-tuning a model on a small private dataset, say your own internal documents, doesn't reduce your risk. It does the exact opposite. It dramatically increases the risk of leakage because you're forcing the model to over-focus on that data, making it extremely likely to memorize and repeat it. This is a very high-risk activity that you have to manage carefully. So what happens if something gets through those first two stages? Well, stage 3, output filtering, is your last line of defense. Think of it like a security guard at the exit door. As the model generates a response, you have scanners checking it for PII, you have filters that can block known sensitive phrases, and you can even have it trigger a human review if an output looks sketchy. It's all about catching a leak before it ever gets out the door. Finally, stage 4 is continuous monitoring, because security is never a set-it-and-forget-it task. You have to be actively hunting for weaknesses. That means regular red team testing, where your own security team tries to break the model and extract data. A really clever technique is using canary tokens. You basically plant fake but realistic-looking sensitive data in your training set. If that fake data ever shows up in an output, bang, you have an instant undeniable warning that your model is leaking. Okay, so we have the framework. We've gone through the theory. Now let's turn this into action. How can you take this back to your team and figure out where you stand right now? This table is a simple way to do a quick gut check of your organization's risk level. Just look at that high risk column. Are you training on raw customer data? Fine-tuning on confidential docs without strong controls? No output filtering? If any of that sounds familiar, you're in the high-risk zone and need to act fast. The goal, obviously, is to move your operations systematically over to what you see in that lower risk column. And the legal exposure here, it's huge. For all the compliance officers watching, this is for you. Think about it. Under GDPR, how do you honor a right to be forgotten request when that person's data is permanently baked into a model? It's almost impossible. Under CCPA, all those consumer data rights absolutely apply to your AI training sets. And that fair use argument for training on copyrighted stuff, it's getting weaker and weaker in court. And if you need one number to really drive home the urgency, remember this: 72. Under GDPR, you have 72 hours to notify regulators from the moment you discover a personal data breach. The second your canary token goes off, the second a user reports a leak, that clock starts ticking. Your incident response plan is not a nice-to-have, it's an absolute operational necessity. So let's just quickly recap the most critical things to remember. First, leakage is not a bug. It's just how these models work. Second, training data is in there forever. Third, your only real defense is that multi-stage strategy we talked about. Fourth, be incredibly careful when fine-tuning on private data. That's a huge risk area. And finally, all of this means that prevention is the only truly effective strategy you've got. So I'll leave you with this final thought. Right now, somewhere in your company, an AI is learning from your data. After everything we've just covered, ask yourself, are you completely confident you know what it's choosing to memorize? Thanks for joining me.